All right, welcome to Tech Talks. So if you haven't done so already, if you have any kind of computing device, that might include cell phones, if you could put that away. If you have headphones, make sure that those get safely put away as well. So make sure that people have a moment to do that. All right, so the first of our two talks today is Rene Eaton. She is the co-founder and CEO of RapidMade. She has over 25 years of manufacturing management experience. Before starting RapidMade, she taught management classes and career planning at the University of Portland, and she has earned her MBA. So thank you, Renee.
Oh, I'm pretty loud, so I don't know if we need this. We good?
Yeah.
You can hear me? Okay.
Just push the button.
The green light, right?
Yeah.
There we go. Great. So it sounds like a lot of you know a fair amount about 3D printing. So anyone here not know what 3D printing is? That's great. I will tell you, when we started the business, we were getting calls for people thinking we were a cleaning service. We spent half our time trying to explain what 3D printing was. And then, things really started to take off. So now we spend a lot of our time, yes?
Why do people think it was a cleaning product?
It's called RapidMade. And so when they heard made, they weren't thinking about making things, they were thinking about cleaning things.
Okay.
So there you have it. So how many of you in your classes have already 3D printed something? Wow, that's great. Excellent. That's excellent. So you all know that in order for that to occur, you first have to have a digital file that tells the printer what to print, right? Because printers aren't, they're smart, but they're not that smart. They need someone or something to tell them what to do. So a lot of our time is spent helping people understand what's a good file and what a bad file is. We also spend a lot of our time helping people understand that, yeah, you can 3D print that, but no, you don't want to 3D print that. So I will tell you, that's not the only thing we do. Sometimes we do a hybrid where we will digitize an item and then manufacture it in a traditional way. Why might we do that? 3D printing is cool. Why might we want to traditionally make something instead of 3D printing it? Yeah?
Because it saves more materials, probably.
Actually, that's an interesting point. Usually, 3D printing saves materials, right? So in traditional manufacturing, you take a block, more often than not, and you cut it down to the size you want. Then you have to assemble all the bits, right? Yes?
Could it be for the type of materials you use?
Yes.
So maybe there's some things that can't be 3D printed.
Yes. So 3D printing, as most of you know, because you're building in layers, sometimes it's not as strong. So if you really need the strength, unless you're willing to pay a lot of money to get that strength, then sometimes it's just better to do traditional manufacturing. There's a couple of other reasons why. So one is cost.
Oh yeah, I was gonna just say overall price.
Yeah.
Manufacturing with 3D printing on an industrial scale is pretty expensive.
Yes. So a lot of it's around volume. So you call me up and you say, I need 100,000 screws. You're never going to 3D print 100,000 screws. It's too slow, it's too expensive, and there's a lot of traditional manufacturing out there that can do it way cheaper, right? So then the reverse is, why would you want to 3D print? What are some of the benefits? Why would I ever be able to sell anything given that it's often more expensive? Yes? Say again? Yes, you can be precise, right? So remember I said traditionally you make all these parts and then you have to assemble them all together. You can 3D print an assembly in one piece. So I don't have it with me today, but there's a ball inside of a ball inside of a ball that you can't even traditionally manufacture, but I can 3D print that because I have a file that says there's a ball inside of a ball inside of a ball, and I can print it that way, right? What fields are really big on 3D printing right now? You may or may not know this. Who do you think really is an early adopter? Yes?
Space agencies?
Yes. Why is aerospace such a hot 3D printing? Yeah.
for testing, like aerodynamics?
There is some testing that's going into it, but what do we know about the airline industry? Planes are what that make them expensive? Yeah.
They're made of like iron and stuff.
Yeah, which is
Head.
heavy, right? So fuel is very expensive. And so if you can make a plane lighter that make it strong enough that it doesn't fall out of the sky, then you are going to be a really popular plane manufacturer, right? So the plane industry, along with GE, they've widely started to adopt this strategy. So they're trying to figure out what parts can be printed and what parts can't. And then they're printing them because titanium's very expensive. And because it's very expensive, you want to put as little in there as possible, right? So you can literally design a part that's as strong, doesn't take as much material, and you're not throwing any of it away. There's another industry that's really taking a, yes?
Isn't like Adidas starting to use like 3D printed shoes?
Yeah, so the apparel industry in select ways are trying to do that. Why?
Oh, I was just
Oh.
gonna say like guns, I guess.
Oh, guns. We're going to talk about that in a minute. Hang on to that for one. Yeah.
Cars.
Cars are getting into it because of design issues, but there's one industry that's really hot right now.
The medical industry?
Yes, medical. Okay, I shattered my wrist in 2012. They took and put a plate in it, and that plate was an off-the-shelf item. And they fit my bones to the plate instead of the other way around. And that's changing. So medical is adopting it because it's highly customized, right? If you lose a finger, you want the prosthesis that you're wearing to match your finger, not someone else's finger, right? And like we actually did this job. We had a client who had a head injury and had surgery done and wanted to physically see what the surgeons had done. So he brought in a CT scan, which is a digital file, and we were able to print a replica of his skull, and he could see what work had been done on it. Now, that's after the fact. Why would a surgeon be interested in doing that before the fact? Yeah.
Practice.
Yes, right? You want them to know what they're doing before they go in, right? So practice is one reason. A related reason is,
Are you saying that why would they want to scan before they do the surgery?
okay, to practice, right? Because some surgeries are very involved.
Yeah.
And you're going in literally not knowing what you're going to see as much as you'd like to, right? So you get these really exotic surgeries where they're like separating twins and things, and the surgery's like 20 hours long, and you want to get a sense of what you're going to be dealing with, so they might practice ahead of time. You might be an intern and they want you to practice before you come into the surgery. One of the main reasons it's so widely adopted is operating room time is so expensive that if a surgeon can shave even 5 or 10 minutes off of a surgery, he's saving the hospital thousands of dollars. Not to mention the fact that that means the patient's under anesthesia for a lot less time. So the other reason is they'll take a replica of that body part and they'll plan the surgery ahead of time so they can reduce the time it takes to actually perform it. So those are the industries that are really into it. What else do you know about 3D printing? Is it a single approach or is it a family approach? If you came to me and said you'd want me to 3D print something, what would you get? Say again? You would get a single right now, although I will tell you that's starting to change because that's one of the deficits, to your point, is 3D printing. Typically, you tell me you want a 3D print and you get a thing in a material, right? They are starting to come up with ways to print in multiple materials, and they're getting closer. I'm going to guess that the things that you 3D printed look similar to this in terms of the material, right? This is probably the most common type of 3D printing. It's called fused deposition modeling, and it's a glorified hot melt gun. We heat it up, we squirt it where we want it, and then you get some kind of geometric figure, right? Fairly hard I mean, you can see the layer lines. You would want to be careful with the application because you don't want the layer lines to split, but it's a good form and fit check kind of thing, and it's relatively inexpensive. But if you were to call us and say you wanted us to do 3D printing, the first thing we would do is find out if that was the most appropriate. Because again, if you wanted large volume, if you didn't have a lot of money, or if there was an issue around the strength or material, we might go to traditional manufacturing instead. Once we kind of work through it and say, yeah, you probably do want to 3D print that, the next thing we're going to try to determine is what is most important to you. In terms of, is it appearance, is it strength, is it cost, is it speed? Why? Anyone know the answer to this? Yeah?
You can get the most accurate.
Yeah. So each 3D printing technology has its own strengths and weaknesses. FDM is cheap, but it's slow. All right, and it's not as clean as PolyJet. How many of you have ever been to a dentist and they've squirted liquid in your mouth and then hit it with a light gun? That is a form of 3D printing in effect. So if you came to us and you said, what I really need is high resolution, I want this part to look, you know, less obvious as a 3D print, right? I don't want the lines to show, then I might do a PolyJet, which is where you take the liquid and the file tells the printer where to hit the light to fuse it, right? So it's the same basic idea. You're taking the light to harden the material, right? This was all printed in one go. And this is actually a chain link, several parts fused as one. So you could see why if you had an assembly that was really complicated and required all these parts to be put together, something like this might be cheaper. If you came to me and you said, this is a model and what I'm really most interested in is color. I'm going to try to sell this massive pump to customers and I don't want to haul this pump all over the country, so I want a desktop version of it that I can show you. Then we might do a ColorJet. Okay, the ColorJet, it's one of the few printers out there where you can get actual color. I've taken pictures and literally have printed them just like I did this one to show what you can do with respect to the color. You can do dimensions and so forth. This is relatively inexpensive. It is a cosmetic piece, which means you can't use it without breaking it, because this is literally gypsum board that's ground together and then fused with a binding agent and then ultimately hardened with super glue, basically. Okay, but if you needed color and you wanted something that you know, had the right shape, now you would always, in all these cases, you need a file. So if you didn't have a file, we'd have to scan it first to digitize it, right? So you know the difference between that, obviously, because you've had the classes. We did for Fox Films. This is a broken version of it, but does anybody recognize the character? I can't remember the name of the film. The Museum, Night of the Museum, or Living it. They wanted to pass these out, right, as a promotional, right? So we did like hundreds of these Owen Wilson characters and the Roman soldier, whoever he was. But you can see, I can't even pass it around because you can see how it's broken already. The material's not that robust. Okay, so one of the biggest challenges with 3D printing adoption has been speed. Okay, until recently, it would take like a day often to print a part. And then HP came out and said, hey, we can do 2D printing, we think we can do 3D printing, and we think we can do it better and faster. So anybody know what technology they adopted to do that? Okay, it's nylon. It's a nylon-based powder that uses a binding agent, a fusing agent, to create the part. Because it's nylon, it is much cheaper, and because of the way they designed the machine, it's 10 times faster. So it's less than half the cost, and it's 10 times faster, and it's production quality parts that we're now getting out of it. And so I will tell you, much of our business has shifted to this because I can sell parts now. It's not just prototyping. And we are getting a number of customers. We're doing prosthetics for some customers. We're doing some finished cases for other customers. And it's really moving the bar in terms of adoption, right? So more and more companies now can do 3D printing. For the reasons I mentioned before, the answer is not always 3D printing. So I'll share a case study with you. How many of you have seen the Deadliest Catch? Okay, so in the summer, I think I got that right. In the summer, they take the boats out on tour, right? They're not catching crabs, so they'll take people out and they'll basically show them what they do. So one of the captains contacted us and said, hey, we're losing a lot of crabs because when people go out with us, they expect to see a crab when we pull the trap up. And he said, these crabs are hundreds of dollars. Not to mention the fact it's kind of a cruel thing to do to a crab and then not eat it. But these crabs are like this big and they're like 50 some pounds. So the guy was losing a lot of money. And he said, can you 3D print them for us? And we're like, well, we could, but that would be awfully expensive. So he shipped us 2 crabs. And if we wanted to 3D print them, what's the first thing we have to do? Scan, right? So we scanned these crabs, and recognizing that 3D printing wasn't going to be the best way to go, we took the scans and we printed the parts to make a pattern. And that pattern was then used to make a mold, which allowed us to traditionally manufacture this. So basically, this was 3D printed. We then, have you ever had, I guess you're too young, you wouldn't have had a replacement tooth, but did you ever get that, they put that goo in your mouth to get the impression of your tooth? That's basically what we did. We squirted goo around this, we let it harden, that gave us the pattern, and then the pattern was used to make a mold, and that's how we created these parts. So we poured the resin in, let it harden, then we assembled the crab. So
Modern blacksmithing.
yeah, so now out in the out by the Aleutian Islands, there's like 200 of these things sitting in the sea somewhere. Another job we had that was molded and not printed. We had an ice cream company and they wanted samples, you know, that wouldn't melt. So we came up with that. And you've heard of Ninkasi? This is more of an engineering project that you might find interesting. Have any of you heard of Ninkasi's brew called Out of This World beer? I think you should know this, but Ninkasi has a beer that it sells called Out of This World beer. And to be able to legally call it that, they had to find a way to shoot yeast into space so that they could say that it was in fact out of this world beer. So they contacted us and asked us would we design the container for them to put the yeast in so that it would survive this trip into outer space and back. So we had to design that from scratch, right? So who would we have given that job to at work? If I need someone to design, right? You don't. So here's the point, right? We have to have files to either traditionally or additively manufacture something. If you don't have files, how do you get files? You can scan it if it exists, but if it doesn't exist, how do you get files? You have to design them, right? So if you want to go into design, what types of jobs would you, what careers would you pursue? Product design, which typically involves what discipline? What would you major in? There's a couple of options actually.
Mechanical engineering.
Mechanical engineering would certainly be one.
Art, wouldn't it be?
Say again?
Couldn't it be like aerospace engineering?
It could be. So you're right, because a lot of them specialize, right? So if you go into aerospace, you have to be an aerospace engineer. They probably have mechanical engineers as well. I heard someone say art. And the answer is yes, as an industrial designer. Because that art still has to involve digital creation of files, right? Because the machines are stupid and they need someone to tell them what to make, right? So in our business, what types of professions do you think we have? Who do we typically hire?
Coders.
Say again?
Coders.
Not coders so much as, and here's why, because the printers already have software that tell them what to do. So we would need coders if we didn't have the software to begin with, but because we have the software, yes. Yeah. So designers, 3D designers, we have mechanical engineers, and the mechanical engineers do a lot of this will perform the functions that it isn't required. But sometimes engineers will come up with things that work but aren't necessarily pleasing to customers. So what other profession might we want to have to work with the engineers to come up with a product? Yes?
Salespeople.
We absolutely need salespeople, right? Because someone has to be the interface with the customer. And I'll talk in a minute about how that process works. But in terms of the design itself, what else would we use? Yeah?
Like sculptors.
We actually don't use sculptors. And the reason we don't use sculptors is we rely on design. We have a mold maker who sculpts with mold materials, but he's not actually a sculptor. Industrial designers, for what I was thinking of, right? So you have the industrial designers are more focused on being able to take what the customer tells them and come up with something that's pleasing, right? Whereas an engineer has to worry about function. To a greater extent, the industrial designer worries about form, right? So you can create a shoe, but if nobody wants to wear it, then that's really not going to work so well for you, right? As a company. Salespeople, right? So in our case, one of the challenges we have is that everything we make is really unique, right? So you'll come to us and the product that you have may actually be just a sketch on a piece of paper, and you want us to help you launch this product that's never been produced before. So everything's highly customized. So that's where the salespeople come in, because a big part of what we do is educating them about what can and cannot be done and how much it's going to cost. And then they'll kind of shepherd the customer through to the end of the product or project along with the other staff. Yes?
And so, how many customers have you had that, like, because of your salespeople, had to like change the design of their product just slightly so you can make it?
That happens a lot. And I will tell you, that's one of the hardest things to get customers to understand. Someone will come to you with a great idea, and you have to really help them understand that it's going to take thousands of dollars before they're going to even be able to have something that they can show an investor to get somebody to invest in their idea. And the reason for that is that so much of it's around prototyping. We have some customers that are on Rev 26, you know, and you print the part and they're like tweaking it. No, that's not quite what I wanted. You know, it doesn't fit, or it doesn't form, it doesn't, you know, move the way we want it to, so then they go back to the drawing board. Sometimes we're the ones doing that design, sometimes they're the ones doing that design, and then we're just printing it. But thousands of dollars in most cases, yes?
Do you guys have any kind of like refund policy?
If it becomes clear that what the customer thought they were going to get is not something, in other words, if we should have caught it sooner, then yes, in that case we may. But in most cases, the reality is, one of the greatest things we can do for a customer is look at the file ahead of time and say, this is not going to work the way you want it to.
Yeah.
Right? And then it's kind of like, do you still want to proceed? If you want to, we have to get an engineer to fix your file so that it will give you what you want. That's the big difference between someone like us and Shapeways. You send a file to Shapeways, they're going to ship back to you whatever you gave them. And they're going to say, this is what you gave us and this is what you get. Whereas we're going to say, that those walls aren't thick enough to hold up. You're going to really regret if we make this for you. What other jobs might be involved? So you have designers that actually get the files. And you have salespeople who get the sales. What other technical jobs might you have? You know?
engineers for maintenance?
Say again?
Engineers for maintenance.
We don't need engineers for maintenance, and the main reason for that is because most of our printing companies require us to have a maintenance plan with them. So if the machine breaks, they expect us to let them come in and fix it. We do have 3D printing technicians, right? So someone has to service the machine. And probably one of the most important things, now how many of you have actually printed something on a printer? How many parts did you have in the printer when you printed it? How many parts?
Just like a piece, like a slip of paper.
So you had, sorry?
One slip of paper.
Yeah, so it was like one piece, right? On our printers are industrial size, they're big. We're producing many parts, sometimes hundreds of parts in one build. Now in order to do that, someone has to literally figure out what's going to go in the build and where and, you know, on what level. Why would we do that?
Why would you do that?
Yeah, why do we need someone to literally
Just
say
to
this
service
part
it.
should be here and this part should be there?
I guess to make sure that everything works properly, especially with customers. You don't want to say like, oh yeah, we're gonna make this, and all of a sudden you make it and it turns out like crap.
Yeah. Were you, sorry, go ahead.
Optimizing space.
Yes, optimizing space. Printers are expensive. So if I'm only like 80% full on my build, I'm losing a lot of money. Now, if you go the other way and you try to fit too much in there, you're going to have exactly what you said. So we will get some parts and they have to go in the build this way, and if they go in the build this way, then they warp. If they go in this way, then maybe the strength on the layers isn't what you need, right? So then you get some of those defects. So you have to have somebody who's specially trained to analyze what all the parts are, where they need to go. The other reason, and you probably know this, is that builds that rely on heat, printers that rely on heat, vary across the build. So some parts of the build are hotter than other parts, and if you're not careful about what you put where, you get the defects that you guys were talking about. And if you're a business, that's really expensive. Some of these materials, if you're dealing in metal, metal is obscenely expensive as a material. You do not want to be throwing those builds out. So we have 3D printing technicians who service the printers. They create the builds, they service the printers, they do all of the programming related to the builds themselves. As 3D printers yourselves, what happens after the printer is printed? What do you do?
Cut it out.
Yeah. So you have some type of post-processing, right? And it depends. In your case, if you're doing it with FDM, you're breaking it off the support, you know, and maybe cleaning it up a bit. If it's a polyjet, you have to wash it off, right? HP is a very similar thing. It has excess powder around that has to be removed. It's a nylon powder. So in some cases, we have machine operators who are sandblasting the part to make it smoother. They might be tumbling it to make it smoother. Some of our customers, these things come out gray. They don't want gray, they want black. They have to be dyed. Some of the times they have to be painted or covered with an epoxy of some sort based on the application that the customer has in mind. So we have a lot of employees that are basically what we call finishers who will work with that. Now, one thing we do that's kind of cool, and I don't have an example of it here, but because we can 3D print tools, you know how we did this part with you know, like a casting process like I talked about? The other thing we do a lot of is thermoforming. So say you're a surgeon and you want all of the instruments that you need for a specific type of operation all in one place so that you don't lose anything. You could come to us, we could design the tray, we could 3D print the tooling to produce the tray, and then we do it on thermoforming. So what thermoforming is it's a form of traditional manufacturing that involves a tool that has a specific shape. You take plastic, you heat that plastic up almost to melting point, and then you vacuum the plastic against the mold. Right, so you get a finished part that way. So You know your cars? You know the lights on your cars that have that fancy plastic cover so that you can see the light? Those are thermoform parts. See all those really kind of intricate designs that they have? That's all done with a tool in thermoforming. And then you'll trim it and ship it. Now we're not doing hundreds and thousands of those, but we do get customers that want maybe 200 chocolate molds, or maybe it's a bath bomb or something, and they want a specific shape, and we'll mold that shape for them to then use in their own production processes. So a lot of times we're doing basically, we're a vendor to a manufacturer that's making something traditionally. And any questions? I think I'm running out of time here. Yeah.
On your 3D prints, do you guys have like support material as well for your 3D build?
Yeah. Almost all of the printers require some type of support while the material is hardening. So to your point, that's what our post-processing people do. They have to then take the print and remove that excess material. Yeah.
Do you require the files to have those already in, or do the engineers add it?
Have the support material in it. More often than not, the printer interface is able to determine where that needs to go based on the file, so that the file uploads and it's a specific geometric shape, and based on where the technician puts them, that determines where the support material goes. But to your point, they need to know enough about how the printer's going to perform to know that if it goes in this orientation, it might warp, and they may have to put it in a different way. Yeah.
For like the little nylon, what'd you say was the?
This.
Yeah. That.
Yeah.
How much in cost, like for materials, did that cost you? And then how much would you charge for something if I went in and asked to buy that?
That's a great question. I will tell you, it depends a lot on the ratio of material to support. It depends on what else we can put in the build. So if you call me up on a Friday and I have to have this on a Sunday or a Monday, because I can't fill the build up, it's going to make the cost insanely expensive. What I can tell you is that we can't really do anything for less than $150. Now we do have certain customers that have very small parts in the HP Jet Fusion, and those parts are a lot more affordable. Like we're actually starting to get to the point where we can sell individual parts for like $20, but we don't do that. I mean, everything we do is business to business, right? We're not getting, someone off the street saying, hey, can you 3D print my dog? I could, but it would be ridiculously expensive to 3D print your dog. Yeah.
So because 3D printing is becoming like a lot more available to people just at home and stuff.
Mm-hmm.
How long does it take normally for someone to kind of learn how to be able to start 3D printing their own?
That's a great question. I would suspect, based on your backgrounds, that you probably know the answer better than I do. Because I will tell you, I don't know how to 3D print anything. Okay, I'm a manufacturer by trade. I had 20 years of manufacturing before we started our business. I'm not an engineer by trade. I have a business degree. My son is our 3D printing expert, and he could tell you anything you wanted to know. And I will tell you that when we started the business, he didn't know anything. He was going to go into the hotel industry. That's what started the business. I was like, that is such a bad idea. Please don't do that. So we said, we were manufacturers, my husband and I, and we wanted to start the business. And we said, we're going to do this with you. Let's see how it works. And he is now an expert in additive manufacturing. My suspicion is for some of the more basic applications, you guys probably already have enough information to be able to do it. Now, you couldn't do it with some of the other technologies, right? Because it is technology specific. But once you know how to design a file, generally speaking, you have a lot of options in terms of how it's printed. There was someone in the back and I didn't. Yeah?
So when it comes to building of homes, do you use concrete? Do you print with concrete, or what do you print with?
That's an excellent question. There is an entire field of 3D printing companies that are doing nothing but construction. And they're taking, to your point, they're taking these cement-based 3D printers and applying the same principle that you use for the fused deposition modeling machine you have to spit out concrete. And they are printing these things in a day. And I'm seeing prices like for $10,000 you can have, not a massive house, but certainly something printed in 24 hours. And it is absolutely going to become, I think, much more widely adopted. I think where it's going to start is when you see a town wiped out by a disaster and they need to very quickly get these homes erected. I think that's really where they're starting to see an opportunity in terms of cement-based 3D printing. Yeah.
How many factories are there and how many like employees in each factory?
For us?
Yeah.
Okay, we are actually a small Portland-based 3D printing company. We have 4 3D printers. They're all industrial. They're all different types. We partner with other entities for the metal because we don't get enough orders for metal to have our own machines. And we have a partnership with a specific type of glass-filled nylon 3D printing. Again, because there's some call for it, but not enough to make us want to have our own machines. And we have all of our own Thermo Forming equipment. But we are Portland-based. We have chosen not to become part of a larger organization. There are some companies like Shapeways is a big one, Proto Labs is another big one, where they do in fact have plants in different cities. We have about 15 employees. Yeah.
How much does chemical engineering come into what you do?
You know, that's an excellent question. Although we do not use chemical engineers, the 3D printing companies in particular do. So HP, they're coming in on a regular basis talking to us about what are your customers asking for? What's most important to them? And I will tell you, material engineering is going to be a big deal because we can only print it if you can figure out a way for us to be able to print it. And there are other types of materials. We are very limited in that, generally speaking, we are printing a single material at a time. And what you all know about the shoes that you're wearing, as an example, made of many different materials. So they're typically printing one of those materials and then using traditional manufacturing for all the others. So the materials piece is going to be huge. How do we print some of these other materials? How do we do it in a cost-effective way, right? Because again, you don't want a lot of failure. Like when we first got the HP Jet Fusion, we were working very hard to reduce the number of failures we were having because it was a new technology and it was temperamental. And so that kind of thing is a really important issue, not just for the companies that buy the equipment, but for the companies that sell it. Because if it's not a reliable 3D printer, you're not going to be in business for very long. So materials are a huge piece, and chemical engineers obviously are involved in that to a large degree. Yes?
So as the quality of like the printers that we can get in our homes improves, at what point do you think that like industrial grade production quality printers that you guys operate will be able to, like, we can buy those as like a general consumer for our homes?
You know, that's a great question. My suspicion is that the price point will drop. These printers cost hundreds of thousands of dollars, so that price point really has to drop. What is likely to happen is that you'll be able to afford the next grade up, which is the professional grade, right? So the biggest distinction in printers is generally size. So the ones that you have for the desktop, they're good enough, but they're small, you know. So then the next level up is for the professional user who isn't actually necessarily selling his own parts, but he might be an engineer and he doesn't want to have to use someone like us to do his own prototyping, right? So then the professional grade is the next level, slightly larger, more reliable. I think consumer adoption is going to take longer than people think, and I think one of the reasons isn't just the cost, but it's that whole thing about needing different materials, right? So until, it's not like, oh, that people thought, oh, we're going to be able to like print our own shoes at home. No, not anytime soon, and if you could, it's going to be a plastic shoe made out of one material that's incredibly uncomfortable, right? But it's coming, and I will tell you, as a business owner, we're looking really long and hard at which of our customers is likely to buy their own machine and not use us anymore. So we're constantly trying to think of how can we be so indispensable to them that they never want us to, they never want to displace us. And one of the biggest reasons is engineering, right? If I can help you solve a business problem, you're always going to need me, whether you have a printer or not. So the engineering piece is pretty important. Awesome, thank you.